J. Mendel proposed three inheritance laws. So, those three inheritance laws are law of dominance, law of segregation, law of independent settlement. So, to explaining about law of dominance, law of segregation, Mendel choosing monohybrid cross. So, to explaining about law of independent assignment, Mendel choosing dihybrid cross. Now, we have to explain about law of dominance, law of segregation by using the monohybrid cross. Now, monohybrid cross. Monohybrid cross. Here, mono means single. Okay. Here means the cross between the single pair of characters is called as the monohybrid cross. So there are 7 pairs of characters are there in tree plant, observed by the great John Mendel. We already know about 7 pairs of characters. One is stem length, flower color and flower position, seed color, seed shape, and pod color, pod shape. These are the 7 pairs of characters we already observed in previous video. Now, in these 7, so for the explaining about law of dominance in monohybrid class, Mendel taken only 1 pair of character. So, such a class is called as the monohybrid class. So if you observe the monohybrid class, by the choosing the 1 pair of characters from the 7 pairs of character, so tall character crossed with the dwarf character plant. Tall tree plant crossed with the dwarf tree plant. So, in first generation, tall plants will be produced. Tall tree plants are cross-hybridized with the dwarf tree plants. These are the parents. In first step, 100% tall plants will be produced. This is called as the F1 generation. F1 means first filial generation. So here, in first filial generation, in F1 generation, total plants are tall. So these tall plants are self-pollinated. In next generation, 75% or tall plants will be produced, 25% or dwarf plants will be produced. Here, see, tall tree plant cross-hybridized with the dwarf tree plant. But in F1 generation, total plants, tall plants will be produced. The dominant character is tall. But internally, dwarf characters are present in tall plant. That dwarf one acts as a dominant in next generation, that is F2 generation, as 25%. So 75% act as a tall and 25% act as a dwarf. This dwarf transferred from the first parents into the F1 generation, F1 to the F2 generation. So to understanding more easily about this monohybrid class, so scientists have taken the upper and lower case of the alphabets. That is, dominant character given as capital letter, recessive character given as small letter. To understanding more easily about this monohybrid class, scientists are given the capital letter to the dominant characters, small letter to the recessive characters. See, what is the dominant character here? Tall. Because in F1 generation, the characters are clearly visible outside. The outside visible characters are called as the dominant. That is why here that tall character is the dominant. That is why tall, capital T, capital T. Automatically dwarf is a recessive. That is why a recessive character denoted with the small one. That is why small t, small t. Always the small one denoted as recessive, the capital one denoted as the dominant. So by using the symbols, now we have to see the monohybrid class. So tall, capital T, capital T. Dwarf, small t, small t. These are the parents. Next, gametes. To form the gametes, the genes are involved in the meiosis division and separates into single. That is why capital T, capital T. Here also same gametes. Small t, small t. Okay. So any one of the gamete from the one parent, another gamete from the another parent cross hybridized form a one trait. Okay, one trait. The trait is capital T, here small t. So this is the F1 generation. Here the capital T small t is nothing but the capital dominant over small. That is why the capital character is a tall. The capital character is a tall. The dwarf character is the small character is the dwarf. That is why the tall character dominate over on dwarf. That is why capital T, small t. But the trait, the plant looks like tall, but internally which contain the dwarf character. Now this F1 generation plant self-pollinated. In F2 generation, if you observe the Punnett square, capital T, small t, because self-pollinated, that is why same horizontally and vertically. So capital T, small t, capital T, small t. If you fill these box, capital T, capital T, capital T, small t, capital T, small t, small t, small t. So if you observe this square also called as the Punnett square. First time observed by the Punnett, that is why Punnett square. So if you observe the Punnett square, see 75% plants are the tall, 25%, 25%, 25%, 75%. These plants also tall, total 75. Here no capital letter. Here no capital T. Two genes are small t's. That is why this is a dwarf. So 25% plants are the dwarf. So 75% plants are the tall. 25% plants are the dwarf. Then the phenotype ratio is, phenotype means what? Physical appearance of the plant. The physical phenotype means simple phenotype. The plant which is visible to outside. What is the visible of this plant? Tall. This one tall. This one tall. This one dwarf. The total 25, 25, 25. What is the tall percentage? 75%. Tall. East. Dwarf. Tall. 75%. So here there is no capital T. So that is why this is a dwarf. So what percentage here? 25%. The dwarf percentage is the 25. If you take the least number, 25 ones are 25 threes are, then 3 is to 1. This is the phenotype ratio of the monohybrid cross. So if you observe the another ratio, that is genotype ratio. See, we already know about what is homozygous and what is heterozygous. I already explained in previous video. So homozygous. Homozygous means what? Homozygous. The similar genes are called as the homozygous. The dissimilar nature of the genes are called as the heterozygous. Here, what is this capital T, capital T? Here, two genes are similar in nature. That is why it is homozygous. What is this capital T, small t? These two are the dissimilar nature of the genes. That is why capital T, small t, capital T, small t. Dissimilar nature of the genes, how many here? Two. That is why these two are called as the heterozygous. Okay. So, what is this homozygous? Tall. What is this heterozygous? Tall. The clear outside visible character is a tall, but internally which contain recessive character. But externally which is visible as dominant, which is visible as tall, but internally which contain small one. What is that? Dwarf. Here there is no internal dwarf character. Both characters are same. That is why it is homozygous. Here there is no internal and external characters are same. That is why this is a heterozygous. There are heterozygous tall are 2 and homozygous tall are 1. Heterozygous tall are 2. Last one, small t, small t. Okay, small t. This is the small t. Which character? Dwarf character. So both characters are same, externally, internally, but the plant visible as a dwarf. That is why it is homozygous or heterozygous. This is a homozygous because two genes are similar in nature. That is why it is homozygous. Homozygous tall or dwarf? It is dwarf. So that is why dwarf. So the genotype ratio is the homozygous tall is to heterozygous tall is to homozygous dwarf is equal to how much? 1 is to 2 is to 1. This is the genotype ratio. This is the genotype ratio of the monohybrid cross. So, how can we explain about law of dominance by using the monohybrid cross? What is law of dominance? See, law of dominance, simple. Dominance means outside visible characters. Outside visible character. So, what is meant by law of dominance here? Any one of the parental character act as a dominant in F1 generation. Whatever it may be, tall or dwarf, whatever it may be, either tall or dwarf. Any one of the parental characters act as a dominant in F1 generation is called as the law of dominance. Here, parents are tall, here dwarf. What is F1 generation? Tall. Here, the tall self-pollinator. What is F2 generation? Tall dwarf, whatever it may be. So in F1 generation, tall may come or dwarf may come, whatever it may be. So that principle is called as the law of dominance. Instead of the tall and dwarf, the F1 generation does not produce the middle size of the plant. So that is why here F1 generation contain all our plants are tall. That is why it is the law of dominance. So by using the monohybrid class, we can explain easily law of dominance. So in law of dominance or in monohybrid class, in NEET and EAMCET purposes, they are asking some different type of questions. How they are asking the questions? See, simple. Now I am going to ask some questions by using these monohybrid class. Simple. Phenotype ratio 3:1. Tall is to dwarf. Genotype ratio homozygous tall is to heterozygous tall is to homozygous dwarf is equal to 1:2:1. So instead of these two ratios, sometimes they are asking like what is the ratio of dominant parent is to recessive parent. Recessive parent. So they are asking like this in EAMCET and NEET. What is the question? What is the ratio of the dominant parent and recessive parent in this monohybrid class? See, what is the dominant parent F1 generation? Tall or dwarf? Which plant produced in F1 generation? Tall plant or dwarf? That is a tall. The parent is the dominant parent is the automatically tall. Then what is the dominant recessive character? The character which is present internally dwarf. That is why recessive parent is the dwarf. So what they are asking there? Dominant parent is the recessive parent. So how many capital T capital T's are there in Punnett square? 1 is equal to 1. How many small t's are there in Punnett square? 1. So small t is to 1. Then dominant parent is to recessive parent is equal to 25% is to 25% is equal to 1 is to 1. So this is the answer. Next question. So what is the ratio of the parental ratio is to recombinant ratio? Recombinant ratio. Parental ratio. What are the parents here? See, like by using this monohybrid class, they are asking what is the ratio of the parental ratio and the recombinant ratio. Simple. What are the parents here? Tall and dwarf. How many tall and dwarf plants here? 2. First one and last one. Capital T is a tall. These two are so tall, but these are not pure. These two are impure. Okay. This one is the homozygous. This is the heterozygous because both genes are dissimilar. Here both genes are similar. That is why homozygous. This looks like a parent. Here small t, it is a dwarf parent. How many parental traits are there? 2. So here parental ratio is the 2. Recombinant. Recombinant means one is tall, in 2 genes, one is tall and one is dwarf. So such plants are called as the recombinant. The recombinant plant is nothing but the trait, the plant containing the both parental characters called as the recombinant. So what is recombinant here? The trait, the plant which contains the both parental characters. Both parental characters called as the recombinant. How many here? The capital T, small t, which contain both parental characters. Here capital T, small t, which contain both parental characters. How many here? 2. So that is why recombinant ratio is 2. Then say 1 is to 1 like this. So these are the ratios. They are commonly asking in EAMCET and NEET purposes. The same time, probability. They are oftenly asking the probability by using the monohybrid class. Monohybrid class. So probability, sorry. What is the probability of the tall? So what is the probability of the tall here? See, total how many here? 4. In 4, how many talls are there? 3. What is the probability automatically? 75% plants are the tall. Dwarf. What is the dwarf probability? What is the dwarf probability? How many dwarf plants are here? Only 1. So what is the probability? 25%. So instead of the tall and dwarf, they often asking like this: what is the probability of the homozygous tall and dwarf? Homozygous tall. Homozygous tall. They commonly asking the what is the probability of the homozygous tall? How many homozygous tall here? 1. So 1 homozygous tall is there. So total 4. So In 4, one homozygous tall is there, that is why 25% is the homozygous tall probability. Heterozygous tall probability. What is the heterozygous tall probability? Heterozygous, nothing but recombinants. This is a homozygous. This is a homozygous. These two are heterozygous. So 25. How much? 50%. The 50% is the heterozygous tall probability. Homozygous dwarf probability 25%. They are asking like this commonly in M.Sc and NEET purposes. So commonly, see, in F1 generation is nothing but the parental plants are cross-hybridized. Some plants are produced in next generation. Such plants are called as the first filial generation, are also called as the F1 generation plants. In F1 generation, the total plants are dominant as a top. 100% plants are the tall plants are there. Okay, so this is about monohybrid cross. Simple. By using the monohybrid cross, Mendel explained about law of dominance. What is dominance? What is law of dominance here? See, any one of the parental character acts as a dominant, either tall or dwarf. Here, F1 generation tall is there. That is why the law of dominance satisfied. So, if the dwarf is present, then also law of dominance satisfied. So, instead of the tall, dwarf is there, then law of dominance satisfied. Instead of the dwarf, tall is there, then also law of dominance satisfied. Instead of the tall and dwarf, other character also there, other character is there, then law of dominance not satisfied. That dominance is called as the incomplete dominance. So, this is about monohybrid cross. By using the monohybrid cross, Mendel explaining about law of dominance, as well as he explained about ratios of parental ratios, and as well as recombinant ratios and dominant ratios, recessive ratios and phenotype ratios and genotype ratios, as well as probability also. He explained about probability and homozygous tall and heterozygous tall and homozygous dwarf probability, as well as tall probability and nothing but